Okay. So, what am I up here for? Um, when it comes down to it, a lot of science education these days has been sabotaged by people who really want it to be about indoctrinating their children, their followers. You know, to them, a knowledge is something to serve a selfish end. And I could say easily, that's a problem there. You guys realize it. You feel it in your bones these days. A sense that everything is being led into a kind of AI hallucination. And the irony is, while AI might be taking over, it's not taking over because it's gotten so smart and all of a sudden knows everything. No, nah, it's uh, it's taking over because people think it's smart because it gives certain people power over what is considered smart. Just look at what Elon Musk is doing with his grok. Every time it doesn't give him the answers he wants, he reprograms it. I mean, that's sort of like, you know, you're saying we should follow the computer because the computer gets it right, and then the computer tells him something he doesn't want to hear, and all of a sudden, no, we've got to reprogram it. Let me go through a few pet peeves. We can start with the idea that our um, of teach the controversy. Now, why do we teach the controversy? Well, a one big reason to teach the controversy is to get everybody focused on trying to turn it into a rhetorical debate. That is a debate whose basic purpose is, to score points on one side or the other, pro or con. And this is the thing, science is not just simply, oh, you have to accept any theory in order to be considered open minded. Now, it isn't, people talk about asking questions, but science in its own way is all about asking questions. But these people aren't clear on what exactly the way those questions are going to be asked. They're not exactly clear on it. I mean, we're always told that a hypothesis is guess, an educated guess. But then people go, oh, I need to be able to. assert my opinion on the subject, uh, regardless. Let's see. Let's see if I can get this better shot. Bugging me where my head's ending up. They're wanting to say it doesn't matter if I'm educated or not because I'm one of the truth tellers. You know, it doesn't matter whether I've got scientific results to it doesn't matter where I got scientific results to back my conclusion. Um, I'm just I'm right because I'm with the right people because I champion the right cause. None of that matters when it comes to science because science is not about. I mean, okay, let's take an example here. Some guy says that the reason why they're coming up with evidence of global warming is because that is what the grants tell them they have to come up with. You know how you disprove that? Look at the evidence. That's the thing right there. Look at the evidence. The evidence will tell you who is wrong, who is right. If you have the evidence down solid, you will be able to take folks who have lied, who have committed scientific fraud, and expose them. Note that's not what they do. We also see this in terms of, say, um, global warming. They'll tell you global warming is a hoax. They offer scientific evidence of this. Well, they try and make themselves look like they're doing that, but they don't really. Like, okay, what do the scientists provide among other things? They provide thermodynamic equations. Like, okay, this much wattage over the whole of the Earth from the sun. That's how much sunshine is coming in. That's how much energy we have to do the work of climate with. Because basically, climate is basically the energy of the sun doing work within our atmosphere to cause weather, and then skipping out to um, radiating back out into space. It's what we're doing as a what they call a black body. Um, sun warms us. We stay warm for a little while and radiate back out the energy after we're done with it. The thing about carbon dioxide when it comes down to it is that it is sort of it makes the path longer, if you will. Things are scattered this way and that in the infrared spectrum, so the the infrared has the chance to warm the air, and this is important because that's what makes us warm when we step out. I mean, this is the thing you often see, and it's like you have this much energy coming in, and they can do a simulation that can say, okay, this should happen. They can hindcast. Basically, they start with the initial information, the initial state of things in the past, and because climate and weather and things like that are um, what you can call because they are deterministic. That is, one initial set of starting factors leads to one outcome. Because they are that way, you can test your theory by going back, finding what the past initial conditions were, and then running your simulation from those initial conditions moving forward. And you can see how well your model simulates what already has happened. You know, that's one way to scientifically test a model. But you won't see our friends in the global warming hoax community, you will not see them actually making a model, making real models. You want to know why? Because that traps them in the world of empirical results. Empirical results they can't deliver. That's the thing. That's why they stay in the world of rhetoric and politics. In rhetoric and politics, you can, you know, make up any conclusion to the story that you want. You can make up any conclusion to the argument that you want. And because you've so cherry picked and so, you know, hijacked people's intuition, you can win there. But if you have to actually put your money where your mouth is, it's not so easy, is it? It's not easy for the people who do actual climate science, who actually come up with the numbers. But they at least are accountable. They at least are starting with a paradigm that can prove or disprove their, their belief, their hypothesis. And that's the thing. We're not looking for multiple. The reason why we will look for multiple theories and try and generate as many of those as possible is not that there are multiple different realities or that everything is just a matter of perspective. No, no, that's not the way it works. There is one reality. And I'm not talking about, let's not get into the weeds on the many worlds interpretation of quantum physics. That's not what I mean by there's one reality. I'm talking there is one set of rules as to how the universe works, about how the world around us works. There's one set of rules as to how biological systems work. But the thing is, we know it all incompletely, and what we do know is kind of only vaguely known in the grand scheme of things. And that, I would say, is a key. That, I would say, is a key. Um, because it's, why science? Why do we go through the scientific method? Why do we test our hypotheses? And what do we test it with? That's that's another thing right there. What do we, when we test our hypotheses, what are we doing? Well, we're using evidence. Why do we use evidence to test hypotheses? Because evidence tells us something about how reality works. If we do an experiment and the experiment yields this and this result, then these and these results reflect something of how reality works. So If, for example, one of my favorite examples is with the Higgs boson. The Higgs boson, we tested, we looked for it by looking for the decay of particles. If I remember correctly, photons. There'd be, these heavy particles would decay into a stream of particles, and the thing that you could detect from it were, I think, a pair of gamma ray um, photons. So they're like light photons, only much more energetic. Um, and we used this, CERN's um, detectors for the experiment. We used those to pick up on this signal of increased, gamma ray decay, if I've got that part right, because I'm going off of memory here. And that enabled us to say, oh, there's something here because we detected that. We might not have detected it. The world didn't have a Higgs boson or didn't have it at that particular energy level. We would have seen a much flattened curve in that area. We would have not seen a sort of a signal. We would not have seen a sort of a sign there that, oh, look, there is this particular kind of decay going on, and it's delivering this particular kind of energy. We could have seen, the negation of that not showing up. And if that didn't show up, it would tell us something. What would also tell us something is if something completely unexpected happened. Like there were a number of spikes here, spikes in energy here and there. So what is the point of what I'm saying? There are ways to tell the difference between if your hypothesis is true or if your hypothesis is false. And when we eliminate a false hypothesis, we eliminate a hypothesis that you know that seemed to us to be true, but the evidence then back that up. What we are doing is we are kind of ever so slightly shaping our knowledge, our we're shaping our knowledge and our understanding of the universe ever so more closely to what's actually true. We're seeing a little bit clearer into that clouded reality that we're always living in. So this is why we don't need it to be. This is why we don't need what you could call multiple choice reality, because it's not just all things being equal, anybody can believe anything they want to. That's not the point. That's philosophy, to be blunt. That's just going out there and doing a BS session with your friends while you look up at the stars. Who could live it? What the scientist is trying to do is they're trying to establish what is true knowledge, what is truly the right intuition, truly the right logical result, and what is not. But that can be kind of restrictive for people. Sometimes people do not want to take no or not as much as you might want or whatever for an answer. Sometimes people want a certain conclusion presented before the public. That doesn't make things better. That doesn't make things better. You know, we are not currently living in the universe where you can say global warming is a hoax. We're living in the one where we've just had this monster of a hurricane, a 185 mile per hour wind, 892 millimeters of mercury pressure monster that just tied the Labor Day hurricane for the lowest central pressure of any landfalling hurricane in, well, my guess is recorded history. There may have been one a long time ago that wasn't that was lower than 892 when it hit shore, but if so, we don't know about it, and there's no evidence of it to speak of. So we gotta go with what we gotta go with. We've had three Cat 5 hurricanes. Only one, only one has actually made landfall. The rest were fish storms. And that's, what can happen. I mean, I believe that last year or the year before, when Beryl hit, I believe that one was actually a Cat 5 at some point in its evolution. Fortunately enough, I think it was a strong Cat 1 or low Cat 2 when it ran us over here in Houston. Uh, we actually, my, I think we actually got hit by the eye wall winds in our case, and that was just like murderous heat for what seemed like weeks on end. And I think we got our power back about 2 weeks later, but good lord, that was after God knows how many days of 90-degree weather, Houston summer weather. If you've been through it, you know that around here, um, it is absolutely legal to beat somebody to death with a stick if they say it's only a dry heat, because it's absolutely not a dry heat around here. Uh, um, and that's the thing. People people don't necessarily read the instructions. It seems, uh, they'll say, "Oh, but it was cold in Europe for that one year." Cold in Europe as a an answer to global. The globe is warming. The global climate is warming. They're saying that the answer to that is it was cold in Europe in one particular place, cold in Europe at you know this one year. Okay, let's see. Okay, so um, global climate change means the entire globe, because if it was just Europe, that's not global. We're averaging all temperatures. So what we're talking about here is that all temperatures are experiencing this rise. And it's demonstrable. You can measure it. If folks wanted to say that global warming was a hoax, go out and go out, send out some ships, buy a whole bunch of research vessels, get a whole bunch of like-minded scientists, go out, take temperatures here, there, and everywhere, and then tell us what the global temperature is, and tell us whether it's going up or down. All right, that might be actual scientific response here. But they don't do that. They don't do anything that requires them to put down a result that can be fact checked because they don't want to be stuck in a fact check. They don't want to be stuck in a position where their position is verifiable. That is why they are often going to talk about Marxism, cultural Marxism, communism, you know, big pharma, little pharma, uh, just right pharma, or whatever. I'm not somebody who trusts the pharmaceutical industry implicitly. But you know what my response to that is? My response to that is regulate them. Regulate those SOBs. So that when they try stuff like what that one family tried with the opioids, they get their butts thrown in jail or fined so much that their nose bleeds. It's like friends and neighbors, we want to be doing this sort of thing on an accountable basis, on an evidentiary basis, not on simply this sort of subjective sort of, oh, I'm just going to, um, not on this sort of, subjective, I'm going to stick it to the man sort of way. Because as much as some people need it stuck to them, it needs to be in a way where there is evidence, where there is reason behind it. There's always this sort of Galileo thing that people want to say that they're doing. They want to say that they have established a new paradigm for how the world works, or I mean, they want to say that it's all. They want to say that it's all just the next big thing, the next big thing. Don't believe what you've got right here, right now. Let's go to the next big thing. They'll talk about cycles. They'll talk about, but they might show the Milankovitch cycles from being that those things are slow as hell. They're on a kilo year cycle. 140, 110, 28, the different aspects of Earth's orbit that um, the different aspects of the Earth's orbit that the Milankovitch cycles deal with, they change over tens of thousands of years. Even the shortest one is something like 28,000 years. So it's not going to cause, a difference in warming. It's also worth noting that I'm sorry if I'm getting a little. It's often an argument from ignorance. It's often an argument that tries and pries open this sort of discrepancy for the sake of just pushing in their own beliefs to say that, okay, now that we've pried open this, now that we've won against this belief, now that we've expressed our personal, disbelief against this belief, it we're just going to go with that. Because we don't know anything in particular. I've got my little theory here. I believe it solves everything. Therefore, it solves everything, and bam, it's a textbook fallacy. It's a textbook fallacy. There's a line from my old professor, Dr. Corby, and it's a difference to be a difference has to make a difference. That's one of Corby's rules that he starts his class out with. And I think the key to that is, that there is another phrase out there, a distinction without a difference. Um, and that's the thing. You can say, I can say, I've got the new paradigm here. I've got the new reality, which oddly enough, with so many of these people, is often the old reality dressed up in new logic. And one example of this is flat earther stuff. They're going to kind of paper over the inconsistencies by just sort of making um, eh, let's see if I can get some lunch. I think I'm running low on sugar. Um, okay. So there's often this sort of sense of they're using the paradigm thing as sort of saying, okay, today's science is tentative. Tomorrow's science may be something different. Oh, look, you have discrepancies. Now I've got the true best theory. And they'll talk about cycles. They won't often name the period of the thing because it's a verifiable fact they can get caught out on. They won't often um, They won't often talk about the strength of the influence. Again, because these things can get them caught in a verifiable lie. They won't create a model because that can be verified, but they want to act like they are Galileo. What did Galileo do? Galileo observed satellites around Jupiter, moons around Jupiter, which was more than the current theory would say could be there. Because they believe that all these planets were basically on their own sort of uh, their own sort of spheres of perfection within the cosmos, and when in fact they were just basically chunks of rock and ice and other things that attracted, created satellites, and Galileo observes these satellites, observes things with his. They observe things with their instruments, and this is part of the thing. What advances science so much is that have we have by observations and other things kind of improved our knowledge. Yeah. Well, I'm getting sort of tired here, but I'll talk to y'all later. Good night.